podcast. So we're going to hit 3.4, more with inverses of quadratics. Marissa is competing in the egg drop competition at her school science fair. Competitors in the egg drop competitions are required to create a container in which they place a raw egg and then drop the container from various heights to see if the egg breaks. The winner of the contest is the person whose container is dropped from the greatest height without breaking the egg. Marissa is testing a container she built for the competition. She placed an egg in her container and dropped it from the roof of a building. The height of the egg can be modeled by the function f of x equals negative 16x squared plus 64, where x represents the time in seconds. 1. Define the independent and dependent quantities of f of x. X equals the independent, which equals the time in seconds. F of x equals the dependent, which equals the height of the egg in feet. All right, go ahead and mark out 2. 3. Determine the restrictions on the domain of f of x based on this problem situation. Explain your reasoning. Based on the problem situation, the domain must be x greater than or equal to 0 because only positive values for time make sense. All right, let's take a look at the next page. Graph f of x equals negative 16x squared plus 64 with the restricted domain based on this problem situation. Be sure to label your graph. Okay, so if you would, go ahead and update the graph and table. All right, let's go ahead and graph this in Desmos. So negative 16x squared plus 64. Now I need to adjust the window, so I'm going to go to the wrench. I'm going to adjust it from 0 to 3 to match the graph on the paper, and then 0 to 64. I'm going to pinch and zoom out. Click here and here. So my points are 0, 64, and 2, 0. Okay, let's go ahead and graph those points. 0, 64, 2, 0, Right, so there's your graph. Take some time to update the graph and table. All right. Now domain will be from 0 to 2 in interval notation. In inequality notation, it would be 0 less than or equal to x less than or equal to 2. And then the range in interval notation will be from negative infinity to 64, and in interval notation will be y less than or equal to 64. All right, go ahead and finish up number 4. All right, let's take a look at number 5. Define the independent and dependent quantities of the inverse of f of x. X equals the independent, which equals the height of the egg in feet, and f of x equals the dependent, which equals the time in seconds. All right, let's take a look at 6. What is the domain of range of the inverse of f of x with the restricted domain? Now, the domain and range switch, okay, when you do inverse. So, the domain is now negative infinity to 64, where x is less than or equal to 64. And then the range is bracket 0 to 2, or 0 less than or equal to y, less than or equal to 2. All right, go ahead and finish up number 6. All right, number 7. Graph the inverse of f of x with a restricted domain. You may use different bounds than you used in question 4. Okay, go ahead and update the graph and table. All right, now let's go ahead and graph the points. Now, for the inverse, these switch, okay? So this becomes, all right, let's go ahead and graph those points. So 64, 0, and 0, 2. It's got a little. All right, go ahead and update the graph and table. All right, let's take a look at the next page. Go ahead and mark out this page. All right, activity 3.5, one-to-one functions. In this activity, you will determine the inverse of a function using multiple representations. 1. For each given function, determine the inverse using each representation. Complete a table of values for the function and its inverse. Sketch the graph of the function using a solid line, then sketch the inverse of the function on the same coordinate plane using a dashed line. Write an equation for the inverse. Determine whether the function is a one-to-one function. Explain your reasoning. Okay, let's take a look at A. So we plug in -2 into the function. So 3 times -2 minus 6 is -12. And that point is -212 is about right here. Okay, and then we plug in -1. So 3 times -1 minus 6 is -9. So that's -1, -9. And then we plug in 0. 3 times 0 minus 6 is -6. So 0, -6. Plug in 1. 3 times 1 minus 6 is -3. So 1, -3. And then plug in 2. 3 times 2 minus 6 is 0. So 2, 0. Okay. Go ahead and finish up the table and graph. All right, now for the inverse, we switch these. So this becomes -12, -9, -6, -3, 0. All right, and let's go ahead and graph that. So -12, -2, about right there, just approximating. Okay, -9, -1, it's right there. -6, 0, -3, +1, and 0, 2. Okay. Go ahead and finish up the table and graph. All right. Now let's find the inverse equation algebraically. So to do that, we have f of x equals 3x minus 6. Step 1, change f of x to y. Step 2, switch x and y. So x equals 3y minus 6. And then the final step is to resolve for y. So we add 6 to both sides. So we get x plus 6 equals 3y. And then the last step is we divide everything by 3. So f inverse of x equals x plus 6 divided by 3. All right. Go ahead and finish it up. And then the last one, determine whether the function is a one-to-one function. Explain your reasoning. The function f of x is a one-to-one function because both f of x and the inverse of f of x are functions. All right, go ahead and finish it up. Let's take a look at the next page. The student works 1b and 1c. All right, let's take a look at the next page. Go ahead and mark out this page. All right, let's take a look at the next page. Go ahead and mark out this page. Go ahead and mark out this page. Go ahead and mark out this portion of the page, and then let's look here. 2. Complete each sentence with always, sometimes, or never. A linear function is sometimes a one-to-one function. An exponential function is always a one-to-one function. A quadratic function is never a one-to-one function. A linear absolute value function is never a one-to-one function. All right. Let's take a look at the next page. Go ahead and mark that page out. Go ahead and mark this page out. And then go ahead and start working on your assignment and have a wonderful Wildcat day.